Okay, so same deal as before on the exam. If you redo any of the ones that you got wrong and just send them back to me, then I'll mark you down if they're working right. Um, okay, so any questions? So another reminder, if you haven't gotten it in yet, start working on your homework. There's a few people that haven't done the first one yet. So you should probably be working on the third one, which was posted over the weekend. Okay, so if there are no questions, and we'll move along. I'm hoping to put the last homework assignment up sometime this week. So maybe next couple days. The last one should be up as well. So what I want to cover is to talk about statics. Oops. So I want to talk about static, and then before we talk about static, a little bit more about methods. So we've been using like the getter and setter methods, and then we had a sort of a getter, but it did a little computation. So like on the last drill, when we had the student class, we had ways you can get and set the student's name, for example, and get and set the number of credits. And then there was another method that did some calculations that got the number of that got the tuition amount. But I just wanted to point out that you can have methods call other methods. So for example, you could do something like this. You can make a class, whatever you want to call it, foo. And you can make a method here, let's say public void, I'll just call it A, just to keep it simple. And you can make more methods, like we had another one. Let's make this one private. So, and then let's say I have a main somewhere. So here inside main, if I did something like foo f equals new foo, and then I did f dot a, so we create a foo object. So we create a foo object right here, and then I call the method a, so this would transfer control up here to a, and then would run whatever's inside here. And if I wanted to, I could, so for all the methods we've done so far, they did something and then exited. But there are lots of cases where you'd want a method to call another one of your other methods. So if we wanted it, so A called B, then inside here, we could do something like, I don't know, int x equals B, and then maybe we do something with x. So once we come into A, if we do this line here, then this would make a call to B. So then this would in turn go over here into this B method, do whatever is inside there. This returns some value because it's an integer. So whatever value it is, it gets returned back and gets copied into X, and this would execute. When this thing's done, then it would come back and run whatever comes afterwards. So the main idea here is you can have a method call other methods, and then this method in turn could call another method. So you could have like a big chain of methods calling each other inside your class if you want to. And in fact, it turns out that you could even have the method call itself. So we'll cover this a little bit later. So you could say something like make a call back to A over here. When you do this, it's called recursion. and if you're not careful, then you can get stuck in this loop where it just calls itself over and over again. But we'll stick some things in there to hopefully prevent that from happening. So we'll see later where that's useful. Okay, so I mainly wanted to just mention this about having methods call other methods. When you do this, if this other method B, for example, is only used inside the foo class, like if its only purpose is to like do some internal computation, then you would make it private because you don't need to get to it from outside. But if the outside world had some reason to get to B, then you'd make it public instead. So this is one place where you'd have the difference between public and private. So the private would be just like an internal method. Public would be more external. So I'll give you an example of where you might want to use that. If we go over here. So like on this next homework assignment I put up here, there's this thing that looks kind of long, but it's not quite as bad as it might seem. So this last one is to calculate the day of the week. So basically, given a date like 3/25/2011, spit out that it was whatever day of the week it was, Monday or something. So in here is like this big kind of formula or a bunch of steps to go through to figure out what day of the week a date was. And here are some methods that can be used to help do that. But as far as like if we made this into a class from the outside world, if we do this, so if we made a class for this, and you don't have to, you could just stick it all in some main. We have to put it in some class, but you don't have to make a specific class just for that. But if you had a class for like day of week or something, then you'd have to send in stuff like the month, the day, and the year. And then the only thing you really care about coming out of this thing is what the day of the week is. Like in this case, it's like a number from 1 through 7. Or you could also turn it into like Monday, Tuesday, etc. So as far as like a black box, you put the stuff in, this is what comes out, the day of the week. But internally, to do those calculations, there are all these other steps we have to do, like figure out if this was a leap year and there's other things. And so that's described in these methods over here, like if it's a leap year, figuring out what century it was, and so forth. And so all of these things, on the assignment, you make them into methods. But the outside world doesn't really need to know about these, but you need to know about them internally. And so these would be good candidates to make private methods if you had a class for it. So because they'd only be used inside this class, the outside doesn't care about those. So when you have those kind of methods, they're called helper methods because they would basically help whatever one method you'd have here to get the day of the week that's public. Everything else could be made private. Okay, so any questions about that idea? Methods, calling methods? Okay, there is a limit to how many methods you can call, but it's pretty big, and it depends upon a couple other factors. But you can generally call a method like 100 times or so, maybe more, before you have a chain that's too big. All right, so the next idea I wanted to talk about is this thing static. And so we've been using it in our main. Whenever we do the main class, there's been public static void main. And so what does this static thing mean? And so static is essentially meaning that there's one copy of it. So things that are static, there's one. I should maybe copy one version of it, one instance. And anything that has static in front of it, you can think of it as like it exists with the class design itself. And then anything that's static, it's like the one copy that you can access from every instance. So for example, we had the person class or the student class. In the student class, we had variables like the name and the credits. And then this was like the template or blueprint. And these static variables, you can think of them like they live inside this blueprint or template. So normally, let me make this smaller. So normally we've been making instances of the class. So we made like whatever a Groot. And in the last drill, you sent in the name and the number of credits. There was something else too. Oh, residency. There's one more, yeah. If the person's a resident. And so when we did a line like this created a new student object. Groot, the variable name, referenced it, and then we stored the name, credits, and resident in there. So Groot, true, 12. And then if we made another one for, what was it, Peter? Then here we would have a Peter variable. And we actually stored Peter in there as the name, the residency, like false maybe, and number of credits. So we had like two separate objects with the variables and data that corresponded to Groot and Peter, and then this thing was just the template that described what fields you had inside each instance. And so this is when we have, so these guys like Groot and Peter are considered non-static variables. So when something is non-static, you have your own instance with your own little copy of those data. But if something is declared static, then instead of having like a separate copy over here, something that's static would exist up here in the class, and it would be shared among every instance. So if we made something, I don't know, what would be shared among all students? I can't think of a good example of something you want to make shared among every student. How about, well, so since I can't think of something that would really make sense, I'll just make up a nonsensical thing. So I'll use our good old foo. So let's say we would have a well, how about like, oh, here's maybe one. Maybe like the tuition credits or something. So what did we say it was per student? 200, whatever it was. So let's say we've got, we'd like to share among every single student what the tuition amount is. So then if I made a static variable in this class, call it like resident tuition, and then I could set equal to whatever we had. I forget what it was. So just say 250. And then essentially I could make a variable up here called resident tuition. And set it equal to 250. And And the way to think of this is if I would now have access to this variable from any one of these objects. And so Groot could access that variable, and then Peter could access that variable. So if we did something like Groot dot resident tuition equals 300, then that would change this to 300. And then if Peter tried to access that, it would now be 300. So essentially it's like a variable. If something's static, it's a variable that's shared among all the instances. And so normally you would use this if you had like different instances and they had to somehow communicate with each other. And so one way they could do that would be through one of these static variables. Or if there's something that you needed to make accessible to all the different instances, then you'd make it static. So that's the main difference. Something that's static as a variable up here gets shared among all the instances, whereas something that's not static, like name, you can set to a different value for every instance. So that's the idea with variables. You can also make static methods. So I can make a static method up here, and it's got the same exact idea. So if I had a method here, trying to think of a good example again. What's some operation that would apply to every student? Maybe, how about, this is not, doesn't make too much sense, but maybe something like get president, like you want to know who's the student body president. That's like something that would be sort of common to all the different students. So we can make a method up here, like a static string get president. And then this could return back the name of the student body president. And then this would be a method that you can now access from any one of these things, but it would call this one method. So with the methods, it might seem like, well, what do we get for making a static method? The main advantage is, since the static method exists up here at the blueprint level, you don't have to make an instance of the class to call that method. So normally you have to do like this down here. So normally you'd have to say like student root equals new. And then once you made an instance, then you can give that variable name, a dot, and then you can call some method. So if you have a static method though, you don't need to do that. So you don't need to make an instance of a static method. You can just go directly and say, if this is in the student class, then you can just go straight to student and then dot call whatever your static method is. So a few of you have been using this math.random. We didn't really talk about it, but math.random is an example. This is a method where you can give it the class name math and then a method name like random, and it immediately gives you back a random number. Another one would be math.square root, for example. So if we call this, then you don't have to make an instance of the math object first. You can just call math.square root, give it the value, and it comes back and tells you what the square root of whatever this number is. Okay, so here let me just do a really short example. So if we go back here to this money, let me comment out all this stuff. Actually, I'll just delete it all. So let's say I had some class in here. I'll go ahead and just make it public. Public int. And in this case, our class doesn't do anything terribly exciting. It's going to take a number, and how about it'll add it to itself. So, or basically it's going to multiply by 2. I'll call it that. So here's a pretty silly little method, but you can imagine this would do something more useful than just taking a number and adding it to itself. And right now, if you want to use this, then since this is a non-static method right now, you would have to do the following. You'd have to make a instance of this class introduction. I'll just call it X. And then once I have the instance, so at this point I've made a copy of this object, and I don't even have any variables inside here I can set, so it's a little pointless in this example. And then if I want to use that, I'd make a new variable. I'll just call it I equals multiply by, I'd say x dot multiply by 2, and then give it some number. Oops, I picked the wrong thing. Multiply by 2. All right, so this has been the way we have done this sort of normally. And so if I run this, then we get errors. Whoops, what did I do wrong here? Oops, I had too many curly braces. So here we get our exciting value of 6 right there. But if instead we make this thing static, and we stick static right here, just like you did it with main, if this is static, then I don't have to bother making an instance of the class anymore. So I could take that line out, and then instead of X here, I give it the class name of class introduction, and then this should work just like before, where here now I get the same 6, but I didn't have to bother making a class. So you can use the static method essentially whenever you have a method that's totally self-contained, where you can totally compute the result based on anything you send in. So in this case, this number 3 I'm sending in, that's all it needs to do its work. If it needed to do some operation on like data for that individual class instance, then you can't use a static method for it. Okay, so once again, if I draw a little picture here, you have the class design or blueprint. If I have anything that's static here, then essentially the static stuff knows about each other. So this means if you made a static method, then inside that static method, you could access static variables. But if I make instances of this class, so if I have an instance here, whatever, like Groot and Peter, and it's got other different non-static variables, like the name or the number of credits. These non-static variables could be different, and they probably will be different. And so you can think of these as like kind of separate spaces. The static stuff has no access to these non-static things because at this blueprint design level, there's no way to know what kind of individual variables you would have at different instances. And so static methods can access static variables, but not non-static. So non-static things, inaccessible from a static method. But you can go the other way around. From a non-static area, you can access the static things. So any code I have here that's not static, it's fine for me to go ahead and access the static ones because there's just one copy that's shared among all these different instances. So it's a little confusing. It takes some getting used to. But the main idea is with static, you got one copy of it. It's basically shared among all instances. And you can apply it to methods or to variables. So here I have a little example with the variables. And we can just step through it here and see what it does. So here's a little output test class. And maybe what we'll do is we'll just start here in main and just step through it, and then we'll see how it's working. So when we run this, we'd start out here inside main, and the first thing it does is it makes an instance of output test I1. So I'll make an I1 and reference a little box for an output test. When it makes an output test, we have two variables that it makes. One of them is a static int, and so once this goes into its special location, so I'll stick it up here. So here's counter, and it's got the value 0. Getting attacked by a mosquito. And then the other one is not static. It's an int called num, and so every instance we make gets its own copy of num. So here I'll have a num, and then when we make this, it calls the constructor. So remember here I have nothing in parentheses, so it's going to call this default constructor right here, which adds 1 to the counter. Well, that's the static variable, so this becomes 1. And then it sets num equal to counter, and so well, num is the non-static one, so that's this thing, so that gets equal to counter, which is 1. So that was done in the constructor. And then right here it goes and calls print info. And so print info is going to go and just print out I am instance. In this case num, which is 1, of counter, which is also 1. So it'll say I am 1 of 1. That's it for instance 1. Now it comes down here for I2 and makes another output test. So I'll put it up here. And when it does this output test, it creates the new instance of it. It does the same thing. It has a num variable, and it calls the constructor. It adds 1 to counter. Well, there's only one counter that's shared among all these, so it's this one. That becomes 2. And then it sets its num to the counter, and so its num gets set to 2. Now we make an I3, and it does the same thing. So here's I3. And in the constructor for I3, it adds 1 to the counter, and then it sets its num to the counter, so it becomes 3. And then we do I3 print info, And so this will say I am instance 3 of counter, which is 3. And so now here we make an I4, and the same exact thing happens. In the constructor for output test, it adds 1 to the counter, it becomes 4, and then it sets its num to the counter, so this becomes 4. And then we do an I3.printinfo, and so for I3's printinfo, it will say I'm instance, and then its num is 3, but then counter is 4. So this will say I am 3 of 4. So this is kind of interesting because the very first time we did I3.printinfo, it said I am 3 of 3. But then the second time we did I3.printinfo, it said I am 3 of 4. And so this counter got incremented from 3 to 4 in between the I3.printinfos. And then lastly, if we do I4.printinfo, it'll say I am count instance 4 of 4, since its number is 4 and the counter up here is 4. So once again, the main idea, if you make something static, there's only one of them. And in this case, that counter is shared among all the instances. So here it's counting how many instances we've made. And so this has the total number of instances made. And then this one has like the number when we actually created that instance. Okay, so any questions about this static concept? So for the drill, I have you doing something really similar to this, where it pops up a window, and when you click on buttons, it'll either add to the static one or not. All right, so what I want to mention to do next here is say a little bit about scoping, which we've kind of touched on a little bit already. So the idea of scoping tells us where a variable lives. Or not just a variable, it could also be a method. So any identifier we make, so it tells us where an identifier, like a variable, where it exists in the program, so when it's created and when it gets destroyed. And then certainly if something's created and destroyed, you can only access it inside that chunk where it exists. And the basic rule for variable and identifier scoping is the identifier lives inside the curly braces where it's defined. So if we're talking about variables, for example, the variables are only accessible and they only exist inside the curly braces where we create them. So if this is our class over here and we make an integer called var, then this var was defined inside this curly brace and that one. So if we go to the block of curly braces where we created that variable, then now this variable you can access anywhere inside these curly braces, and that's where it lives. And then essentially you can access that anywhere inside this class. But then if this class ever goes away, or if you're outside the class, then you can't normally directly access that variable. Over here, let's see. So this variable var you can access from here because this method's inside the class, and you could also access it here and some other method because it's also inside that class. So this is why if we make variables inside the class, they're like fields for that class that should apply to any method you'd use in the class. However, if you're outside the class, like down here, then you can't directly access this variable by name. So you can't just say whatever var equals 3 or something, because var is defined inside a different class. However, if you had an instance of the foo class, so if you had like foo x equals new foo, and if this was public instead of private, then you could say x.var, and then you could access it from outside as long as you had an instance to go through. But if you're not going through an instance, then you can only get to things if it's defined inside the same curly braces. So don't make the mistake of being in a totally separate class and then trying to do things like var equals 10 or something, because you can't do that. Let's see. So along those same lines, oops, I didn't do it here. If we did something like this, public. And so if we had some variables on these methods, like x1 as a parameter, and then this other one x2, this would be considered a local variable. Both of these are considered to be created within these curly braces, even though this one kind of is outside of the curly braces, but it's considered part of the method, which these are the curly braces for that method. And so both of these variables would only exist inside this method. So x2 here I could use inside here once the method is gone, or if we're in this other method over here, then we can't access any of those variables. So if I try to say something like x1 equals 10, can't do it because x1 only belongs to this first method. Same thing for x2. If I try to set x2 equal to 20, I can't do it. x2 only exists in here. And in fact, I could have another x2 over here, and I could have another x1, and then this x2 and this x1 would be a totally separate one from the x2 and x1 inside the first method, and these would only exist inside this pair of curly braces. So this is usually considered good, because if you have like one person writing this method and another person writing this one, then you can both pick the same variable names, and then you won't be messing up each other's variables, because whatever name you pick is just going to be totally separate from whatever name someone else picks here, even if it's the same. Okay. Where are we here? All right, so this brings up the possibility for some interesting things. So here, let's look at the sample program, and then we'll see how we can get around some possible issues. Did I miss something? Oops, I skipped. I meant to have another version in here, but I forgot to put it in. All right. All right, sorry about that. Let me just move this. And A equals Um, okay. Um, all right, so sorry, I meant to copy and paste this in, but missed it. All right, I think I copied it how I wanted. Oops, or don't have an I here. Probably should have just retyped it. Okay. Okay, so so we were just saying up here, if we define a variable like x2 or x1, these variables only exist inside the block where it was created. So in this case, they only exist inside their method. So what if we have a variable with the same name in different blocks? So here I have a variable named a that exists up here as a class level variable. And then I could make another variable called a that's here inside this method here called doIt. So let's just see what happens. If I come in over here, x gets set to a new output test. So x is an output test. Output test has a variable a. And then right here we go and set a to 100. And this is not really good practice to make it public and set it from outside, but just for purposes of an example, here we set it to 100. Then we go in here and we call doIt. And inside doIt, we make another variable called a, and then we set it to 3. And so two things could happen. One is you could go to this variable a and change it to 3. Or we could have another variable a that gets set to 3. And that's what happens in this case. When you have a variable a, this makes a local variable that exists only inside this method. And then it sets that to 3. This variable a that's in the class isn't changed. This just shows that inside more sub curly braces, I can access that variable. And so if we do a print line, which a is it going to print? Well, it ends up using the a that's defined most closely to where we're at. So here it uses the most closely defined a, which in this case, you think of it pops up one level here and it's got this a in the method. So this would print 3. Back out here, this would print out 3 again. It uses the same a. So inside these sub curly braces, I can still access the a from outside. And then this thing returns out here. When it returns back over here, it prints out x.a, which is this a, and that one prints out 100. So bottom line, if you have two variables of the same name, but one of them is inside a method, and then the other one is one of these class variables, then if you access that variable, it's going to use the one that's defined inside the method instead. What if you didn't want to use the one in the method? Then we could do this. You can use the word this in front, and then dot. And whenever you use the this, it's going to reference the current object. And so in this example, the do-it was called off of object X right here. And then object X's A value is 100. And so when we say this dot A, then you would get 100 right here instead of the 3. So that's how you can distinguish between a local variable and one of these class variables if they have the same name, is you stick the this in front, and then that can access the class level variable. Some people like to do that all the time, and especially if you're using an IDE, for example, then there are some benefits. So if I make let's see, I'll just make it private. So I have a variable called sum variable, and let's say I have another int sum variable. So if I just say sum variable equals 10, it's going to use the local sum variable. If I want to access this one up here, then I say this dot this. Oh, I can't do that because it's static. Sorry. If you have a static method, you can't use the this, because the this refers to the current instance, but there is no current instance if it's static. So anyways, so I say this dot, and then now I can do the sum variable, and then that would be changing this one up here. I'll go back to the non-static one. So some people like to always use this, especially with an IDE, because then when you use the dot, you get this little, you get the pop-up thing, and then it can kind of help remind you like what you called your variable, like sum variable. So it gives you a little extra help in terms of what methods you defined and what variables you've got accessible. It also makes it a little bit easier just for someone that's reading this. If there's a this in front, then you know that it's a class level thing. And then if there's not a this in front, then you might know it's a method defined variable. Okay, one thing I should mention you can't do is you're not allowed to do this. You can't have the same variable name in the same scope, I mean. So you can't say like int x equals 3 and then do stuff, and then in the same scope say int x equals 10. So this would be like defining a variable 2 times in the same scope. You can't do it. The compiler will say, when it gets to this one, it'll say x was already defined or something. And then you can't do it in a lower scope either. Like you can't have some set of curly braces and then make another x here. So this isn't allowed either. So once you've made an x in some method scope, you can't redefine it a second time. So what I wrote right here, where I have this set of curly braces, is usually kind of unusual just to have curly braces by itself. But more normally, you'd put this like inside a loop or an if statement or something. And so that's what this other example was down here. And so more typically, you'd have something like this. Here's a method with the variable I. If there's a subblock right here where we define an A, so notice we haven't defined any other A inside this method yet, even though there's a class one. Here we make an A, we set it to 1, print it. When we reach this right curly brace, that variable A is destroyed, this one. This A goes away because it was defined in these curly braces. And this one in the class is still there. Here's another set where we make another A, set it to 2 and print it out, and then it's also destroyed. And so when we get over here, if there is a loop and we try to make an A, then this would create a new A that only exists inside here. but then it exits, or it's destroyed when we get to that right curly brace and exit the loop. So essentially, here's a case where we made 3 separate A's. They each exist inside their little chunk of curly braces. These first 2 are, you wouldn't normally do this. It's just kind of for illustrative purposes. But here would be the more typical way. You have something like a while loop or an if statement. And if you need a variable that only exists inside this loop, then you could create it right there. Okay. So I think covered those. So then the very last thing I can mention really briefly, and I probably should have mentioned up here. So when we were talking about having methods call methods, you can also have a method appear twice, but it just has to have a different set of parameters. So here, and it's the same idea with constructors. So maybe I'll just do, so we could have like a public void whatever method A. So I could have another one called method A as long as I have something different in the parameter section. So for example, I could make 4 separate things called method A if I wanted to. As long as there's some difference here in the parameters that get sent in. And so then what Java will do is if I have a call to method A and I don't put anything in the parentheses, then it knows, oh, it's going to call this one. And if I have something in here that's like 2 integers, 10 and 12, then I'll say, oh, that matches this one right here. And so it knows to call that one. And so forth. What you can't do would be to have 2 of them that are the same. So if I had int x and int d, and I sent in 1 integer, then Java wouldn't know which one of these 2 methods to use, and so it wouldn't compile. And then the other thing you can't do is you might make one of these have a different return value. So you might say, oh, these are different because one returns double, but one returns an int. Well, Java doesn't look at the return values when it makes the call. And so this wouldn't be allowed either because it would still be confused when you make the call as to which one of these 2 that you're supposed to use. So it's got to be the parameter list that's different when you have the same method name multiple times. This has a special name. It's called method overloading. So an example where you might use this, maybe you're trying to compute the absolute value. So you might say public int absolute value. Let's make this bigger. So you might do this for an integer. So to compute the absolute value, you might say if x is less than 0, return x times -1, otherwise return x. So there is absolute value for an integer, and then you might have another one for a double. So if I'm trying to compute the absolute value of -3.7, then it would know to use this one. And if it was just 3, then it would know to use this one because of the parameters. Now, it might bother you a little bit that the code here looks exactly the same for the different absolute values. And if I was going to do more of these, I could make absolute value with floats and longs and stuff. And then from what we've covered so far, you would have to have a different one for every single different data type you might want the absolute value of. But there is a way you could make it so there's only one of these. We won't cover it in the class, but there's a thing called a template where you could make it so it takes any data type and then computes the absolute value of it. Okay, so I think I'll stop talking here. Are there any questions? Okay, so I'll let you work on the drill and let me know if anything is, if you have questions on it.